Hello students, welcome to eCareerPoint-English YouTube channel. How are you guys? Okay, so everyone is online. So today is our second lecture of our this series of class 12. In the previous class, we have discussed about the GOC topic and we have started class 12. Okay, today we are going to start with GOC part 1, in which we have studied now one of the most important effect, which is known as electromagnetic effect. Electronic displacement effect. Okay, so in the previous class we already discussed about the GOC part 1, in which we have discussed the first mechanism of any organic reaction, and second we have discussed about the bond fission. Okay, today we are going to start electronic displacement effect, which is one of the most important effect, and every year NEET ask these types of questions. Okay, so shall we start? Anyone online? Okay, now so today class we have discussed about, we will start inductive effect. Today we will go with inductive effect. What is inductive effect, its application, and we will do some numerical parts. Okay, shall we start? Okay, if you want any free study material, if you want any free study materials, anyone want or not? If you want free study material, if you want any free study material, you can download from our website eCareerPoint.com. Okay, this is our website, this is our app. You can download these free study material from our app. Okay, these are the 8 important features you can get in our app. So download now eCareerPoint app and subscribe, and you will get 8 these types of 8 our component. Okay, so today we are going to start inductive effect. Today we are going to start our inductive effect. Okay, now what is inductive effect? We already discussed about inductive effect in the previous class. Okay, we already studied about the inductive effect in previous class. Okay, so we already discussed what is this. This is a type of electronic displacement effect. Okay, it is a type of electronic displacement effect. Okay, so what is inductive effect? Generally, the inductive effect due to displacement or shifting of an electron. What? It is generally due to displacement or shifting of an electron pair of sigma bond. This is first point number 1. Okay, here the shifting of electron going to take place of sigma bond only. Here the sigma bond shift from one atom to another atom. Okay, along the carbon chain due to difference of electronegativity. Due to difference of electronegativity. Clear or not? So first point is that you have to remember that shifting of sigma bond between the atoms of molecules, and second, it is shifting due to difference of electronegativity. Clear? So this is clear. This is only a shifting. This effect generally due to shifting of sigma bond. Clear? Now we will take an example of any of the component. Now we will take an example of any of Rx. Clear? Let me say here the electronegativity of R and X. Here the electronegativity of R is greater than X, and here the electronegativity of R is greater than, here the Y electronegativity is greater than R. We will take 2 examples. Okay, now here is Rx, where R have more electronegativity, R is more electronegative and X is less electronegative, and here we will decide that here is R and here is Y, and Y is more electronegative than R. So what are the cases arises and how inductive effect going to take place? Let us take an example. Here these are the 2 electrons which shared by R and X. These are the 2 electrons which are shared by R and X. Now here R is more electronegative, X is less electronegative. So what going to take place? Here the shifting of electron going to take place. Here the shifting of electron going to take place from less electronegative item to more electronegative item, and partial charge will be developed on each atom. Clear? So here we can say that R delta minus plus X delta plus, this is a partial negative charge. So the shifting of electron from X to R due to difference of electronegativity, this is called a inductive effect. Clear? This is case number 1, in which we studied about R having a more electronegativity than X. Okay, second case, if we talk about the second case in which Y having more electronegativity than R, here R having alkyl group having more electronegative, or here is more Y having a more electronegativity. Okay, so what will going to happen, this Y and this R shares one electron forming a covalent bond. Clear? Forming a covalent bond. Here this Y is more electronegative, so electron shifting towards Y take place, and it causes the formation of Y delta minus plus R delta plus partial positive charge. This shifting of electron is known as inductive effect. Clear? Okay, so this is called an inductive effect. Here X is donating electrons to R. Here this X is donated electron to R. So this X is known as electron donating group. This X is known as electron donating group, and we will study further that this X is also causing a plus I effect. What? This causing a plus I effect. We will discuss later. Okay, now here what going to take place? Here Y is withdrawing, pulling the electron of R. Y is pulling the electron of R. So what going to take place here? What going to take place? Y is acting as a electron withdrawing group, because it withdraw electron of R from R and pulling the electron of R. So they are electron withdrawing group, or we can say that they are giving a minus I effect. They are giving a minus I effect. Clear? This is the inductive effect, and due to inductive effect either carbon anion is formed or either carbocation is formed. Clear or not? So this is called, this effect or this shifting of electron is called a inductive effect. Clear? Now second point, it influences the physical and chemical properties of compound. Due to inductive effect, chemical and physical properties are changing. Because why? Due to this X, electron withdrawing group or electron donating group, or due to electron withdrawing group, the properties will be changing. Either the compound will be acidic or basic depending upon the position of this X or this Y. If any group having S number of groups, it means that they are basic. Okay, if the group having a more plus I effect, means the compound is more basic. Second, if compound having more Y, means electron withdrawing group, that means that they are electron withdrawing group, they increases the acidity of compound. How they are increasing their acidity, we will discuss in the next slides. Okay, so this is the concept, or this is why they influence the physical and chemical properties of any compound. Clear? So due to this I effect, the physical and chemical properties of any compound will be changing. Okay, now we will come to next slide. Now inductive effect decreases with the distance. As we move away from any of the electron withdrawing group, what going to take place? Inductive effect decreases. Let's take an example of this, that any of the compound, this is any of the compound and this is X, and here we will take XF any halogens, means compound having more electronegative, either we will take chlorine, fluorine or etc. Means here the compound is attached to more electronegative item. Clear? Here compound is attached to more electronegative item. Clear? So here the shifting of electron take place due to difference of this electronegativity. Here is C and here is X. They are having a difference of electronegativity, so the inductive effect will be changing to take place, and shifting of electron is going to take place, so that here partial positive charge and here partial negative charge will be developed. Clear? Now as we move from right to left, we move away from this X item towards this side, this effect will be decreases with the distance. So this experience a more inductive effect, this effect is more in this, so inductive effect is more, and as we move from here, the inductive effect will be less, here is more less, or we can say that delta double plus, or delta delta plus, and up to this the inductive effect is less, and up to this point inductive effect will be 0. So we can say that as we move away from any of the electron withdrawing group, the inductive effect will be less. Clear? Now inductive effect will be clear. So we can say that inductive effect, is inversely proportional to distance. We can say that inductive effect is inversely proportional to distance. Clear? So inductive effect decreases with the distance up to the third carbon. Up to the third carbon, its effect remains, and after that the inductive effect will be neutralizing. Clear? Now these are the properties of inductive effect. Now we will move forward and divided inductive effect into two parts on the basis of their electronegativity. Okay, so inductive effect will be divided into two parts based on their electronegativity difference. Okay, so inductive effect will be divided into two parts on the basis of electronegativity. Clear? So what are the part? First is minus I effect and second is plus I effect. Minus I effect and this is plus I effect on the basis of electronegativity. Clear? Now what we have studied earlier, due to minus I effect take place when carbon attached to more electronegative item. When carbon or alkyl group is attached to more electronegative item, then we will say that minus I effect going to take place. Clear? Now we will take an example of any of the R. Here is X. Okay, or we will say that X is any halogens, fluorine or chlorine, because here carbon is attached to more electronegative item. What's going to take place? Here shifting of electron going to take place, and and this group is known as produces a minus I effect. This group produces minus I effect. Clear? Now for the same plus I effect, when carbon or alkyl atom is attached to less electronegative item, here carbon or alkyl atom is attached to more electronegative item, then plus I effect going to take place. Clear? Now we will take any example of Rx where X is now a hydrogen atom, means hydrogen is less electronegative than this alkyl group or carbon atom. Now here the shifting of electron take place due to difference of electronegativity, and this carbon is taking electron of this X. Okay, so here what is doing? Plus I effect when carbon is attached to less electronegative item, and minus I effect going to take place when carbon or alkyl atom is attached to more electronegative item. Clear? Now second point is that they are the minus I effect, they are the electron withdrawing group and they are the electron donating group. Let us see example of Rx. Let us take an example of Rx. This X is withdrawing or pulling the electron of R. This X is pulling or withdrawing the electron of R. So we can say that they are electron withdrawing group. Clear? Second, this is called a electron donating group. How? This X is donated electron to this R atom. So we can say that this X is act as the electron donating group, and this X is act as electron withdrawing group. Clear? So second point is that this minus I effect all are electron withdrawing groups, and plus I effect they are electron donating group. Clear? Now third point is that they stabilize the carbon anion. They stabilize the carbon anion and they stabilize the carbocation. Okay, let us take an example of R, and here is any of the X. Here is R minus, means here is any of the carbon anion is present. Now here is X, this is electron donating, electron withdrawing group. So as they pull the electron of this minus ion, the carbon anion going to stable. Clear? This is electron group withdrawing group, they pull the electron of this R minus and this R become a stable. So we can say that this R, they due to this X, they stabilize the carbon anion. Now for second point, they stabilize the carbocation. Let us take the example of R delta plus, and this is X, and here X is less electronegative than R. What they are going to take place? They are electron donating group. So when they donate one electron to this carbocation, they are going to stable. Clear? So minus I effect is stabilizing carbon anion, and plus I effect is stabilizing carbocation. These are the important point of minus I and plus I effect series. Clear or not? Clear? Now we'll move further. Minus I effect series. We already discussed about the minus I effect series, in which we studied about the electron withdrawing group, and for plus I series we discussed about the electron donating group. Clear? So these are the atoms which already we have studied. We will discuss first. This is NR3. R means alkyl group. Okay? NR3 plus having more electron withdrawing capacity. After that we will go for NH3 plus. Okay? These two items you have to remember separately. After that we will go for our trick. Okay? The first trick is this. We will go for N for nitro group, C for cyano group, A for aldehyde, K for our ketone group. Okay? COOH group for acids, fluorine, F for fluorine. And these are all the halogens you have to remember here. So this is cyano, this is for nitro, this is cyano, this is aldehyde, this is ketone, this is acid, this is fluoride, and after that chlorine and iodide. And after that we will go for ethers. They are ethers. Okay? And after that we will go for alcohols. Ethers, alcohols, and after we will go for Y for ine, or we can say that CH triple bond CH. Clear? And after that we will go for A for amines, or PH for phenyl group. This is phenyl group, or we can say that C6H5 group. Okay? This series we already discussed in the previous lecture. Okay? So you have to remember this trick, or we can easily write out the minus I effect series of electron withdrawing group. They are having very strong electron withdrawing capacity, and after we will move further, this capacity will be decreasing. Okay? So from NR3 to phenyl, you have to remember this series, because as per this series or these functional group, you can easily find out the acidity order of the compound. Clear? So this minus I effect series you have to remember. I already discussed this series in previous class. Okay? Now we will go for plus I effect series. Okay? Plus I effect series means they are the electron donating group. What? They are the electron donating group. They are strong tendency to donate electron to other item. Okay? Now, first is we have to use again this trick as CNOA 321. First is CH2 minus, having very strong electron donating group. Okay? After that we will go for NH minus. After that we will go for O minus, C for CH2 minus, N for NH minus, O for O minus, A for carboxylic acid, yani ki carboxylic acid means carboxylate ion. After that we will go for CS3, means tertiary carbon anion. Tertiary carbon anion. After that we will go for secondary carbon anion. This is secondary carbon anion. And after we will go for primary carbon anion, CS3, CH2 minus. And after we will go for only methyl CS3 minus. So this is the decreasing order of their electron withdrawing capacity. Clear? So this is decreasing order of donating capacity. Electron donating capacity. Clear? Now we will go for further as the application part of inductive effect. Clear? We will go for application part of inductive effect. Now in NEET always two type question will be asked, either from stability of carbocation or stability of carbon anion. Okay? Or first question either the stability of carbocation and carbon anion, and for second we know we have to find out the acidity order of different compound. Okay, so two questions will be asked, one from stability, one from acidic strength of compound. Okay, we will discuss the application part, how the stability of any carbon anion going to take place. Let us take an example of carboxylate ion. Clear? We will take an example of carboxylate ion. Now, here is COO minus. This is COO minus. This is, we can say that, carboxylate ion. Clear? Now, COO minus, this minus ion is with carbon ion. Now, if we want to stabilize this COO minus and it is attached with electron withdrawing group, what this is attached to electron withdrawing group, this may be any of the atom which having a more electronegativity than what? Carbon. So we can say that fluorine, chlorine, any of the atom which have more electron withdrawing capacity. So whenever this electron withdrawing group is attached to COO minus, this electron withdrawing group is pulling the electron of C minus and going to stabilize this COO minus. Clear? This is COO minus. This CO minus want to donate one electron to any other atom to become stabilized. Okay. Now, whenever it attached to electron withdrawing group, this electron withdrawing group pulls the electron of COO minus and this stabilize this COO minus group. Okay. So electron withdrawing group or minus I effect going to take place. Electron withdrawing group, what they will do? They will pull the electron and after that they stabilize the carbon anion. So if we say that electron withdrawing group stabilize the carbon anion. Now, if we take an example of electron donating group. Now, electron donating group is attached to COO minus, means carboxylate ion. Electron withdrawing group is attached to any carboxylate ion. Electron donating group is attached to COO minus. Okay, so what going to take place? This atom already is unstable due to presence of this negative charge. If electron donating group is attached to this COO minus, what going to take place? This is already having one electron and this group is donating this electron to this. So what going to happen? This electron donating group destabilize this CO minus because this is already having minus group. Okay, this is already having one minus charge and this electron donating group again donating this electron. So what will happen? This is more unstable, or we can say that this electron donating group destabilize the carbon anion. Okay, so we can say that electron donating group destabilize the carbon anion. Clear? Now, so we can say that any of the electron donating group, electron withdrawing group stabilize the carbon anion, but electron donating group destabilize the carbon anion. Clear or not? So this is the stability order you have to find out. Minus I effect, always minus I effect, or electron withdrawing group stabilize the carbon anion, or electron donating group destabilize, or we can say that electron donating group stabilize the only carbocation. Stabilized carbocation but destabilize carbon anion. Destabilize the carbon anion. Clear or not? Clear now? Okay, so this is the first application of stability of our any carbocation or carbon anion. Now we will go for second part, which is known as acidity of any compound. We have to find out the acidity of any compound. How we can find out? Let us take an example of any acid. Clear? Now we will take an example of any acid. Now we will take HA. Okay, this is any acid. Clear? Now it dissociates to H plus A minus. What? H plus and A minus. HA is dissociated to H plus and A minus, means this is acid and this is converted to A minus is conjugate base of this acid. Clear? Now if we want to write dissociation constant, Ka, means Ka of this equation can we write? Yes. By applying chemical equilibrium formula or trick, we can write the dissociation constant Ka of this equation as, first we will write H plus, first we will write H plus, or we will write of A minus upon we will write of HA. In numerator we write product and in denominator we write this reactant. Okay, so product upon reactant is denoted by Ka value or dissociation constant. Clear? Now, we know that higher the value of Ka, higher the value of dissociation constant, more the acidic strength. More the acidic strength. We already know. As the Ka value increases, as the Ka value is increases, its acidity of compound or acidic strength of any compound will be increases. Clear? Now, one part is again, here Ka is directly proportional to this concentration of A minus, or we can say that Ka directly proportional to concentration of A minus. Clear? Concentration of A minus. Now, or we can say that K is directly proportional to concentration of A minus, or we can say that directly proportional to acidic strength from here. So higher the Ka value, more the stable the conjugate base, higher will be the acidic strength. This is the important point we derived. Okay. So here you can see, more the stable A minus, higher will be the acidic strength. More the stability of A minus, higher will be the acidic strength. Means any of the electron withdrawing group is attached to that carbon, it stabilizes what? Carbon anion. So the more will be the acidic strength. So electron withdrawing group or minus I group, always increases the acidity of compound. Clear? Now, so we can say that higher the minus I effect, higher will be the acidic strength. Okay, so this point we have derived in our equation. Okay, this is very important fundamental we have derived. Okay, so this is application of acidity of inductive effect. Any group having more electron withdrawing group, what this minus I effect do? They withdraw the electron capacity. Okay, so higher the electron withdrawing capacity, more will be the acidic strength we have derived. Clear? So this is the second part. First you have to find out the stability order, or you can find out the what? Acidity order of any compound. Clear? Now we will move further and we have to write the acidity order of the differing functional group. If differing functional group is attached to what? Differing functional group is attached to any of the items, how we can find out the acidity order? So we can write a descending order of acidic strength of many of the functional group, and we will use our trick. You have to remember this. Okay, by this trick you can write the acidity order of any of the compound. Clear? Now we will first write S for sulfonic acid. We will write here first. Okay, here we can write first as sulfonic acid as SO3H. Second, what we have to write? F for formic acid. S for formic acid, SCOOH, formic acid. Second, formic acid. After that we will write benzoic acid. After that we will write benzoic acid as COOH. After that we will write carboxylic acid, means any of the group RC double bond OOH. RC double bond OOH. After that we will write phenol. We will write phenol, P for phenol. This is the decreasing order of their acidic strength. This sulfonic acid have more acidity as compared to other compound. Okay, first this is more acidic, after that this is less acidic, and after that this series will go on. Okay, this P for phenol. After that we will write W for water. We will write W for water. After that we will write A for alcohol, RCOH. Here is star, star means there is one exception. Okay, only one exception. Now, what is here is 3. 3 means we have to write CH triple bond CH. 3 means triple bond here. Okay. After that we have to write N for NH2. Here is NH2. After that we have to write 2. 2 means we have to write CH2 double bond CH2 means alkenes. After that we have to write CH3 single bond CH3 means single bond alkanes. Okay, so this is a decreasing order of acidic strength of different functional group. Here different functional group. Here is sulfonic acid, here is acetic acid, here is phenol, here is alcohol, here is now alkene. So this is a decreasing order of their acidic strength. You have to find out the acidity order in application part of question. Okay, now here we take one exception. There is only one exception between this, that if this alcohol is methyl alcohol means CH3OH, this is methyl alcohol CH3OH, so we can say that the methyl alcohol is more acidic than water as compared to water. So this is only exception. But if we take ethyl alcohol C2H5OH, the acidic strength of this water is more than alcohol. So water is more acidic than alcohol, but we have to remember one compound that is known as methyl alcohol. That is known as methyl alcohol. Clear? So you have to remember this exception, otherwise your question will be wrong. Clear? Can we start our application part? This series you have to remember. Acidic order you have to remember so that you can do the acidic strength of any compound. Clear? Now this is the application part, but this is a brief slide of our inductive effect. Two type question, I already told you, two type of a question will be asked, either from stability or either from acidity of compound. So you have to remember bus these 4 points, that for stability, first stability of compound, as the minus I effect increases, the stability of carbon anion going to increase. Okay, or we can say that any of the electron withdrawing group attached with any of the carbon anion, it increases the stability of carbon anion. Clear? It increases the stability of carbon anion. Second, if plus I effect is directly proportional to stability of carbocations. Stability of carbocations mean any of the electron donating group is attached to compound, that increases the stability of carbocations. Okay, so electron withdrawing group increases the stability of carbon anion, and electron donating group increases the stability of carbocations. Clear? This is for first point, stability of any of the carbocation or carboanion. Now for second type of question of acidity question, first point is you have to remember that minus I effect is increases with acidic strength. Means as the minus I effect increases, acidic strength of compound increases, or we can say that any of the electron withdrawing group is attached to compound, they increases the acidic strength. This is a very important point, very important. Any of the electron withdrawing group increases the acidity of compound. Any of the electron withdrawing group increases the acidic strength of compound, or we can say that it causes minus I effect. So you have to remember minus I effect series, which I have already discussed in previous slide. Okay, you have to remember full series. Okay, now second point, for plus I effect, as we increases plus I effect, what going to take place? Basic strength will be increases. Plus I effect increases with basic strength, or we can say that electron donating group, they donate the electron. Na? Whenever someone donates an electron or lone pair, basic strength increases. Okay, so any of the electron donating group is attached to any of the items or any of the compound, the basic strength of the compound will be increases. Clear? So these two types of the question will be asked in your exam. You have to remember this slide. If you remember this slide, you can easily do the questions related to acidity order or stability order. Clear or not? Okay. Shall we go further for the application part? Okay. We will discuss one by one. First question, previous year question. You have to find out the which aromatic acid among the following is weaker than simple benzoic acid. You have to find out the acidic strength, means second point you have to apply. Okay, you have to find out the which of the following compound having a less acidic strength than benzoic acid. So first we will write a benzoic acid here, COOH. This is a benzoic acid. You have to find out the compound which is weaker than this benzoic acid. Clear? So we already remember one point, that any of the minus I effect or electron withdrawing group is increasing the acidic strength of compound. Any of the electron withdrawing group increases the acidity of compound. So we have to only find out the minus I effect series. From minus I effect series, which one is the electron withdrawing group? Okay. Now, can we say that which is weaker than this simple benzoic acid? Okay. So can we start? First we will see, here is COH, here is COH, again COH and 4. All 4 having a benzoic derivative. Okay. Now, here is chlorine. What it will do? This is the electron withdrawing group. It increases the minus I effect. Okay. It increases the minus I effect. Okay. So it increases the acidity of compound. Means as compared to this benzoic acid, it increases the acidity of compound. Clear? Now, here is nitro group. As per our series of minus I, we can say that this is also a electron withdrawing capacity. So it withdraws the electron and increases the what? Increases the acidity of compound. Means this compound is more acidic than this COH, because this is attached to electron withdrawing group. Third point, this is COH, but this is a CS3. This is methyl group. What it will do? It donates electron, because CS3 is a electron donating group. What it will do? It donates electron to this benzene ring and it causes a plus I effect. It causes a plus I effect means it decreases the acidity of compound. Means as compared to C and as compared to benzoic acid, C and benzoic acid, this is weaker acid than benzoic acid, because this CS3 donates electron to this ring and increases the basicity of this compound. Okay, so this compound is weaker than this. Okay, now we will come to this one. This group having a SCO3. This is having a very good minus I effect, or we can say that they are good electron withdrawing capacity. So we can say that this causes a very minus I effect. So this is more acidic than benzoic acid. Clear? So among all A, B, C and D, this C compound having a weaker than simple benzoic acid. Simple. These type of question will be asked between comparison of different compound. So we have to find out the acidity or basicity order. Clear? So among all the options, option number C is correct for this question. Clear? You have to find out which is weaker acid than benzoic acid. Okay. So the correct option is this question is answer number C. Clear? Now we will move further for question number 2. You have to find out among the following the most basic compound. You have to find out the most basic compound among all. Clear? All are having a aniline, NH2, 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 aniline group. Okay, and you have to find out which one having a more basic compound. Clear? Now, what we will do? First, we will write we will write basic strength. Basic strength is directly proportional to plus I effect. We already discussed in the previous slide. As the electron donating group or electron donating capacity increases, basic strength will be more. Okay. So as the I effect increases, plus I effect increases, basic strength increases, or we can say that it is depend on the electron donating group. So as the electron donating capacity of any of the compound increases, plus I effect increases, or we can say that basic strength increases. So what we have to do, we have to only find out the electron donating group or plus I effect in the compound, or which one having a more plus I effect, that the answer of more basic. Clear? Now we will start with, this is aniline. This is a neutral compound. This is basic in nature, we already know. This is basic in nature. Now can we say that this is NO2 and this is attached to this C6H54? First we will draw the diagram of B. We will draw the diagram of B as this is C6H5NH2 and this is a NO2 group. At para position this NO2 group is attached and this is C6H4 and NH2. Clear? What here will do, this NO2 is a electron withdrawing group and what we will do, it decreases the basicity of compound because it is withdrawing the group, or we can say that it is causing a plus I effect. But we have to find out the compound which gives plus I effect because we have to find out the basic strength of compound. Clear? Now, so this is giving only a minus I effect. Now we will come to C point. Here we will sum to C point. Here is M for meta nitro. So we can say that this is a compound C6H4. It consists of NH2 and at meta position this nitro group is attached. Okay, again we can say that this nitro group is a electron withdrawing group, or we can say that it causes a minus I effect. It causes a minus I effect, but we have to find out the compound which gives plus I effect, because plus I effect increases the basic strength of the compound. Okay, now we will go to D point, option number D. We will say that this is a C6H5, here is CH2 or here is NH2. Here is CH2 and here is NH2. Now we will see that this CH2 donates electron because this CH2 having a strong electron donating capacity. So it donates the electron, means it causes a plus I effect. It causes a plus I effect. So it causes a plus I effect, and with comparison with this D and with A, this is more basic because this group donated the electron and increases the basicity of this benzene ring. Okay, so compare with D and A, we can say that D become a more basic compound as compared to all these. Okay, because you have to find out the most basic compound. So correct option if this compound is option number D. Only these type of question will be asked always. You have to find out the acidity order or you have to find out the basicity order. Okay, so the correct option of this question is option number D. Option number D is the right answer. Clear? We will go for question number 3. Now in this, among these all group, you have to find out the what? Consider the following acid. This is the one, this is second, this is third. You have to write the correct order of their acidic value. Again, always for acidic order or basic order question will be asked from NEET. Okay, so now you already remember that whenever acidic strength, you have to find out what? You have to find out the minus I effect, or we can say that electron withdrawing group. You have to find out the electron withdrawing group. Higher the electron withdrawing capacity, higher will be the acidic strength. Clear? Now can we say that this CH2, now we can say that this is COH, this is COH, this is COH. These are having a acidic group. Okay, now we have to find out along this, or this is ClCH2, this is CH3 and this is CH3CH2. We have to find out the capacity of these group. According to these capacity, we can find out the acidic order. Can we say that this Cl causes minus I effect, this causes plus I effect? Yes, but according to this this is also a more acidic. So we can say that they causes a minus I effect. They causes a minus I effect. Now we will come to CH3. CH3 is a electron donating group. CH3 is a electron donating group, means if it decreases the acidity of any of the compound, or we can say that it decreases the acidity of compound, or it gives plus I effect. What? It gives plus I effect. Now we will move further for CH2, CH3, CH2. Here this is CH3 and this is CH2. These both combine with each other and they are giving a more and more plus I effect. More and more plus I effect. But we have to find out the correct order of acidic value of minus I, means you have to find out the more minus I effect causes more acidic value. So according to all these, this first compound will be a more acidic, as second is more acidic as compared to third. This is second and this is third. This is first, second, third. So the correct order of acidic its value is first greater than second greater than third. So the correct option of this question is option number A. Clear? So these types of question you have to, these types of question will be asked in NEET. So correct option is option number A. Now we will move further for question number 4. Question number 4, you have to find out the correct acidity order of the following compound. You have to find out the correct acidity order. Okay, and this is a very important compound because here 2 groups are phenol and 2 groups are benzoic acid. Again, you have to find out the acidic strength. We already know that minus I effect is directly proportional to electron withdrawing capacity, is directly proportional to acidic strength. But you have to find out the minus I effect or electron withdrawing capacity. Clear? Okay, Russell, I will take daily organic class. Okay, from Monday itself, GOC part will be started. Okay, so join me live on any each alternative days, Monday, Wednesday and Friday. We have started organic. Okay, now minus I effect, you have to see the minus I effect of the compound. Clear? No. So according to this, see the COH and this is COH, and as per series we already know that minus I effect causes what? Minus I, this COH having a more capacity than OH and OH. We already know that. This benzoic derivative is more acidic as compared to phenol. Now we have to compare this and this. These both are more acidic as compared to these two. Clear? Now according to this benzoic acid and this benzoic acid, we have to find out the acidic strength. We have to find out the acidic strength. First is COH, second is COH. Now this causes minus I effect because this is acidic, is more acidic, but this CH3 causes a electron donating group. So it decreases the acidity of compound. It decreases the acidity of compound because CH3, this is electron donating group. So it decreases the acidity of compound. So first we have to write is that we have to write first is third. This is more acidic. This is more acidic as compared to this, because this consists of CH3, which is an electron donating group. It decreases the acidic strength of the compound. Okay, so first we will write 3 and after that we will write 4. Now as compared to this chlorine and phenol, as compared to this two phenol, what we have to do, this is more acidic, but we can write this chlorine having a more minus I effect. So they are electron withdrawing group and it increases the acidity of compound. It increases the acidity of any compound. So we can say that among these two compounds, we can say that the correct option is second. After that, this phenol is less acidic than this, because due to this Cl group, minus I effect will be exerted and this increases the acidic strength of any compound. Clear? So the correct order will be is third, fourth, second and first will be the correct option. Okay, this is the correct option. Third, fourth, second and first will be the correct option. So these types of question will be asked in your NEET exam. In the next class we will discuss more questions. We will do the application part of this minus I effect, and after that we will start the second effect, which is known as resonance effect. This is also a very important effect you have to study. So in the next section we will discuss about the resonance part or inductive part. Clear? Guys, to take care of yourself and we will meet Friday. Till then, take care, make proper notes of my classes and you will clear your NEET exam. Okay. Okay. Thank you and all. Have a fun.